Hey guys, in today's video I will show you how to deal with exponential functions when it comes to finding the derivatives of. Exponential means e to the x power, e to the 5x, e to the something like x squared plus 3 and stuff like this, e to the power. I will walk you through all of these types that might come up and I will break them down. Now, say you have e to the 5x power and you need to find the derivative. In other words, you need to differentiate with respect to x. For all of these problems that I'm going to cover today, keep one thing in mind, that the derivative of e to the x is e to the x. So basically the function remains the same. So e to the u power prime equals e to the u. So as a quick reminder, prime stands for the derivative. You could use divide dx notation, whatever suits you best. So that's the only one function that the derivative of that function remains the same. It's kind of easy to remember. And I'm using this u on purpose to emphasize and highlight that u could be any expression contains x. It could be another function in terms of x. So it's not only just x. It could be x squared, it could be like this 5x, it could be 10x, it could be more complex and complicated function. That's why I'm using u over here. Now, look at this. You have e to the 5x. It's not e to the x, it's e to the 5x. And if you look at this function more closer, you would notice that your function basically is made of another function. You have e not to the x, but e to the 5x. So your function is consists of another function, which is 5x. So basically you are given a composite function of a function. And at this point you have to use the chain rule. What is this mysterious chain rule? And to be perfectly honest with you, I do have a bunch of videos on the chain rule. I will link all of them down below in the description box. I have the first videos on the chain rule where I explained how to use it and when to use it. Also, I do have a special video on how to identify when you should use chain rule and when you shouldn't. It's called a little game, chain rule to be or not to be, because it might be confusing and complicated, especially when you start off doing calculus, differentiated and this stuff. So if you need more help and more examples explained, how to use it, when to use it, so please go ahead and check out these videos. The links will be down below in description box. In a nutshell, chain rule basically says all you need to do to find the derivative of this complicated composite function, if you will, you need to take the derivative of outside function, leaving the inside function as is, untouched, times multiplied by the derivative of inside function. This part very important, since many people forget to do the last part. So you have to also take the derivative of this inside function. Let's break it down. So first of all, try to identify what is your outside function. It's gonna be e. So you are given e to the power, you are given e to the u. And also another way you could think of this as a kind of substitution. You have u equals 5x, if it makes this sense. And honestly, I don't want to confuse you more, but another idea, another way, as I mentioned before, you could think of this as a kind of a substitution, and in reality we do this substitution. But anyway, so let's go ahead and find the derivative. So y prime, and you can call it just y for the convenience, for the sake of convenience. So y prime equals, so the derivative of outside function. So you have e to the power, so it's going to be the same, e to the 5x. 5x. And notice I'm writing 5x, not to the x, because your argument, your inside function is 5x. And chain rule asserts that you need to leave the inside function alone, unused, untouched. So this one, we are not done yet, gets multiplied by the derivative of inside function. So your inside function is 5x. And you need to take the derivative of this inside function. I'm going to just spell everything out and kind of highlight. You could definitely do it in your head, it's not that complicated, but my idea, my point is I want to just spell everything out. All you need to do is just clean it up, and the derivative of 5x is going to be just 5. Recall that the derivative of x is just 1. So instead of these two, we're gonna left with just 5. And typically, we wanna bring this 5 in front, pull it out front as a coefficient, and it's gonna be just 5e to the 5x power. And that's gonna be your derivative for this function. So again, this 5 comes from the derivative of inside function, since the derivative of 5x is just 5. So, and we brought this coefficient in front of your exponential function. Moving on. Here's another one, e raised to the x squared plus 3. Again, definitely you are given a composite function and set up your chain rule detector, so you have to apply, you have to use the chain rule. So again, you have e raised to the power, and your entire power is going to be x squared plus 3. So the derivative of this function, y prime, is going to be, if you call it y, the original function. So chain rule says you need to take the derivative of outside function. Your outside function is the exponential one, so it's e to the power. So it's going to be the same. It's going to be e x squared plus 3. So you don't want to change this exponent, this power. And we are not done yet. So this one gets multiplied by the derivative of inside function. So basically, you need to take the derivative of x squared plus 3. So that's your entire function. That's your entire power. Clean it up. So the derivative of x squared plus 3 is going to be just 2x. Since you have a power and you basically apply this power rule, derivative of 3 is just a constant, it goes away, disappeared. So it just becomes, you want to keep this, and it gets multiplied by just 2x that comes from the second term. Clean it up, we don't want to leave the house like this, and typically since you are given exponential function and algebraic function and they are multiplied together, so you have kind of a transcendental function, so we call them transcendental e, or natural logarithm, or just logarithm of these trig functions, so they're a common name, transcendental, if you will. And typically we put this algebraic function in front, so it's going to be 2x times e raised to this power x squared plus 3. That's going to be your derivative for this original function. And finally, the last one I want to cover in this episode. Say you have been given 3x plus 2 e raised to the square of x. Looks a little bit intimidating and spooky. Let's break it down. First of all, look at this function and try to analyze, try to break it down. First of all, what pops out at you that you are given two chunks, two pieces added together, two completely different functions. First of all, you are given algebraic function, which is 3x, and you are given exponential function e raised to the square of root, whatever. gets multiplied by a coefficient by a number. So, and we need to find the full derivative of this function. So basically, all you do is just find the derivative of the first chunk, which is 3x, and the derivative of the second one. The first one is a kind of a piece of cake, if it makes sense, because the derivative of 3x is going to be just 3, and we're done with the first piece, with the first chunk. The second hunk needs a special attention and a special care. Let's get into this. So the derivative of this, of the first one, so let's call it y, and let's just use another notation, dy dx, or you could stick to your y prime, probably favorite notation because it's kind of a fast and simple way. So 3x, we're gonna left with just 3 instead of the first term. Now, you want to keep this addition, you don't want to change anything, and let's tackle, let's handle the second chunk. So you want to keep this piece, you want to keep this coefficient 2. Now, let's deal with e to the power. So again, you are given e to the u, let's say. The derivative of exponential function remains the same, and you want to write e raised to the square root of x. And again, if you look at this function, in fact, you are given a composite function. Your function consists of another function. You are not given e to the x, you are given e to the square root of x. And this is the moment when the chain rule kicks in. So the derivative of outside function is e to the square root of x, and this function gets multiplied by the derivative of inside function. The inside function is square root of x, and all you need to do is just figure out what is the derivative of square root of x. So the derivative of square root of x is 1 over 2 square root of x. You would think of this as a separate rule, and many people tend to do the same. For me personally, I do remember this special result, this special derivative, since it pops out, it comes out a lot, especially when you do calculus, so it's worth remembering. If you don't want to, or if you don't have to, you could basically obviously derives from a power rule. So the way you would do, you just want to rewrite the square root as a half power, and you want to apply a power rule at this point. Now, let's get back to our other functions. So this outside function gets multiplied by the derivative of this square root. So times 1 over 2 square root of x. So that's the derivative of inside. So again, I'm going to repeat myself. You could either remember this a separate one, and by the way, I do have a special video on 2 derivatives you should memorize. Again, I will link all of these videos related to this topic down below in the description box, and if you are down to this, you could help yourself and check them out later on. Or again, you could, anytime when you when you bump into this square root of x or square root of something, you could derive it from the scratch. Completely up to you. Now, technically, we are done with the derivative, but obviously we are not going to leave this house like this, a kind of a sloppy mess. All you do is just clean it up, and what pops out at you that these 2 and these 2, they could cancel each other out. So this 2 goes away, and I'm going to place this e to the power of root of x on top of my fraction. And we are left with, keep this 3, carry it down, plus e to the root of x goes on top over square root of x. And that's gonna be your derivative for this function. Do not confuse with this power of square root and with this square root of x. So this square root appears as an argument for your exponential function. This square root of x, it's gonna be just a separate algebraic function. So they're completely different. Do not mix them, do not get confused by this. So that's your final result, that's your final derivative for this original function. Alright, I hope it has been helpful to you. Huge thanks for watching and train your brain. I know everyone hates maths, unfortunately. But if you like my video, please hit this like, share with your friends, leave the comments down below, and make sure to smash that subscribe button so you will not miss out my new uploads. And when I'm not...